Welcome to Wireless Visionaries. In this video, we will talk about the three timeless truths in wireless communication. So the first is the demand for wireless throughput, both mobile or fixed network, will always increase as the users are increasing and the requirements of the ground users is increasing. Second, the quantity of electromagnetic spectrum will never increase. That is, the most desirable frequency bands that can propagate through buildings and obstacles will only constitute a small fraction of the entire spectrum, such as sub 10 gigahertz bands. And there is always the communication theorists and engineers will always be pressurized to invest or to discover breakthrough technologies to increase the spectral efficiency of the network. So now, what is spectral efficiency? So spectral efficiency is a measure of how efficiently a communication system utilizes its available frequency to transmit data. Or in other words, we can say amount of data that can be transmitted over a given bandwidth or frequency range. So that is why the unit is bits per second per hertz, the amount of data per second per hertz. Spectral efficiency is a crucial performance metrics because the frequency spectrum is limited and the resources are shared among different users and different services. So more spectral efficiency implies the more data can be transmitted and thus the maximizing the capacity and the performance of the wireless communication system. And higher SC spectral efficiency allows more data, more users to simultaneously serve higher data rates and increasing the overall efficiency of the network. So these are some of the factors that can affect the spectral efficiency, or we can say that can increase the spectral efficiency. So some of that are modulation scheme, multiple access techniques, channel coding, spectrum allocation and sharing, and interference management. We will not go into the depth of these techniques that affects the spectral efficiency. So now what are the three ways by which we can improve the efficiency of the network? Now, given the history of more than a century of wireless innovation, we must look at the physical layer because the amount of information that can be transferred between two locations is limited by the availability of spectrum, the laws of electromagnetic propagation, and the principles of information theory. So, the three basic ways by which we can improve the efficiency of the network is first, we want to deploy the access points more densely, we utilize more spectrum, and we increase the spectral efficiency. That is the number of bits that can be conveyed per second in each unit of bandwidth. Now, either you increase the access point base station density or use the new spectral bands, the need for maximizing the spectral efficiency is never going to vanish. Why so? Because if we see from an example, in 1998, there were 300 million subscribers, and now it is 6 billion subscribers worldwide, which are where the majority of data is currently being utilized for the end user applications, such as the video streaming and the audio streamings, and they generate a bulk of traffic. So to accommodate this drastic and the dramatic growth in the traffic, new air interface for faster transmissions, channel coding for enhanced reliability, improved source compression to remove redundancies, and linear protocols to reduce overheads are some of the ways that are contributing towards this enhancement of the efficiency. And these are the techniques involved in the signal processing. But nowhere these techniques have played a much bigger role than the development of the multi-antenna communication. So that is the main aim of studying the multiple antenna communication. So this is also known as the MIMO, multiple input, multiple output. So currently at the traditional base station, if you can see from the figure 1, currently at the traditionally base station at the cellular side, they feature the antenna panels. They are connected to the baseband unit that manages the digital signal processing. So this area that are covering is called a cell sector, which is vertically narrow, but horizontally it is very wide. So it covers a swath of ground in predefined manner. But now in the current base station, for example in 5G and 4G, these panels have been replaced by the antenna arrays. So antenna array result in radiated beams that can be narrow both horizontally and vertically. For example, this is a beam that is projected towards the ground user and is very narrow. And these all the beams, they are individually controlled by the baseband unit. So how each beam is narrow enough to aim at the particular user can be seen from this figure. So thus, as a result, it can now alter the physical shape of the produced beam over both time and frequency. So what are the benefits of the multiple antenna communication? First is the beam forming gain, second is the spatial diversity, and third is the spatial multiplexing. In the coming video, we will look into what each of the term implies: beam forming gain, spatial diversity, and the spatial multiplexing. Thank you.